All right, so today we're going to be talking about Learning Objective 6-1, which is about wave measurements. In this learning objective, you're going to learn how to distinguish between amplitude, frequency, wavelength, and wave speed. But since this is the beginning of the unit on waves, we first need to talk about what a wave is. And so we're going to be reading right here the definition. What is a wave? A wave is a back and forth vibration or oscillation of a medium that transfers energy from one location to another. So let's use that definition with a couple examples down here. So here we're looking at ocean waves. Ocean waves are the type of wave, and the medium, the material the wave is traveling through, is water. The definition of a wave says that there is a back and forth oscillation of a medium that transfers energy. So in a wave, we have the medium, which is the water. You have little particles of water, and they're oscillating like this. They kind of go up and down, and they kind of go left and right. They basically make a circle. And that oscillation transfers energy from where the wave is created to where the wave crashes on the shore. Let's use the example of sound waves next. Sound waves are a type of wave, and the medium for a sound wave, in this case, is air. Those sound waves can travel through a variety of different things, different materials, and different media. The oscillation here is that the vibration of the needle down here on the record creates an up and down oscillation that is transferred into back and forth oscillations of these air molecules. It's important to realize the air molecules don't actually move from one place to the other. What moves is the energy as one air molecule vibrating triggers the next air molecule to vibrate, and so on and so forth. Another example would be earthquakes. Earthquakes let out a wide variety of waves that travel through the medium of rock. Lastly, we can see electromagnetic radiation. And electromagnetic radiation is special. When we're talking about electromagnetic radiation, we're thinking about things like light, or microwaves, or radio waves, the signals that are sent from a Wi-Fi device to your phone or from your phone to another phone, are all electromagnetic radiation. In order to understand electromagnetic radiation, we need to think back to our previous unit where we learned that a changing electric field, which is drawn in green here, so there's a vibration in the electric field, that changing electric field is going to cause a vibration in the magnetic field, which is drawn here in blue. This is just like when you run a current through a solenoid and it creates a magnet, an electromagnet. We also learned that the opposite is true, and that a changing magnetic field will cause a change in the electric field. And so you can see that the electromagnetic field, the electric and the magnetic field, create radiation because a vibration in one field triggers vibrations in the next field, and those are passed along kind of like people doing the wave, or like one domino hitting the other in a chain. And that is how light and radio waves travel. Now what's special about this is the medium, the electric and magnetic fields, are invisible, and they exist everywhere in the universe. And so these electromagnetic radiations, which are things like radio waves and X-rays and gamma rays and light, are able to travel even through empty space because their medium is everywhere. Sometimes we even say that electromagnetic radiation doesn't require a medium because it doesn't require physical objects like water particles or air particles in order to transfer it. So electromagnetic radiation is definitely special. All right. Now that we understand some types of waves, we understand what a wave is, and we understand its media, let's talk about how to measure a wave. And this is really all about vocabulary. So the first piece of vocabulary is the word peak. Right here we have the peak of this wave. The peak is simply the highest point. Over here we have a trough. The trough is the lowest point. Kind of a hard word to spell, but there it is. The amplitude, as you guys should already know from your investigation, is the height of a wave from sort of the middle of the wave, what we call the equilibrium point, that's the dotted line on my picture here, all the way up to the peak. So here's the amplitude. The wavelength, on the other hand, so amplitude is the height, wavelength is the distance from one peak to the next. Again, it's important for you to be able to distinguish between these things, so understanding why wavelength and amplitude are different is vitally important. The next thing we're going to talk about is wave speed versus frequency. Wave speed is actually the distance a wave's peak travels each second, measured in meters per second, whereas frequency is the number of waves passing a point each second, measured in waves per second. If we look at these waves that I've drawn down here, and we want to look at their wave speed, we would have to think about the waves actually moving from one place to the next. And wave speed would be measured by counting how far the wave moves. So let's say that this is like a distance from here over to the red dotted line of 10 meters. If all of these waves, so if I have a look at wave A right there, its peak is lined up with that starting line. And so it's going to take maybe 1/1000 to 1,000 for that peak to reach the red line. That means that it traveled 10 meters in a time of 2 seconds, which is a velocity of 5 meters per second. Okay, that would be the wave speed. On the other hand, the frequency is how fast waves are generated. It's basically how fast is the vibration up and down that is causing these waves. If we want to measure frequency, we measure it by looking at how many waves pass a certain point, in this case the red dotted line, each second. So again, we're going to move all these waves at the same speed, and we're going to think about which one has the highest frequency. All right, let's do that one more time. Again, we're thinking about which one has the most waves passing the red line each second. And it should be pretty obvious that D, down at the bottom, has by far the most waves passing that line each second. There's a ton of waves there, like about 20 or something like that. And so this wave is going to have something on the order of, we'll say just 10 hertz, which means that there's 10 waves passing the red line each second. C might only have a frequency of about 5 hertz. B only has a frequency of about 2 hertz, only 2 waves pass the line each second. And A might only have a frequency of 1 hertz. So to complete this statement over here, if all waves travel the same wave speed, then A would have the lowest frequency because it's the fewest waves per second, and B would have the highest frequency. Or sorry, not B, I apologize. I always get those two letters mixed up. D would have the highest frequency.